Today we are going to be talking about zeros of polynomial functions. So remember, polynomials are anything that has x to some power, and we want to be able to find zeros. There's lots of stuff that's going on in this section. So we are going to start with the fundamental theorem of algebra, which sounds kind of important. The fundamental theorem of algebra says that if you have a polynomial, degree of at least 1, then f has at least one zero in the complex number system. Okay, so there is at least one zero. It might be a complex number. Another way that you can say that is that if you have a polynomial of degree n, it has n roots or n zeros. Although some of them might be complex numbers and some might appear more than once. Remember the multiplicity? This website here has more information about the fundamental theorem of algebra if you want to find out more about it. But this is the version that we're going to be dealing with more, is that if you have a degree 4 polynomial, there are 4 roots. They might be repeated roots, they might be complex roots, but there are 4 of them. So along with that idea is the linear factorization theorem, is if you have this polynomial, if it's degree n, it has n linear factors. Okay, so you can factor it into linear factors. Linear factors means it's not a x squared or x cubed, it's just an x. Although you may have complex numbers in there. And we'll see an example of that. So just remember, if it's degree 3, that means there are 3 zeros and 3 linear factors. Now, the unfortunate things is these two theorems are called existence theorems. They tell us that solutions exist. It does not tell us how to find them. So that's too bad for us. Okay, number 1. We want to find the number of zeros of this function, and then we're going to find them. So we take a look at that and see that it is x to the 4th, which means there are 4 zeros. Also means there are 4 factors, so we should be able to factor this into 4 linear factors. So now we're going to do that. So, factoring this, hopefully you can see that this is a difference of squares. This is x squared squared minus 1 squared. So we can factor this into x squared minus 1, x squared plus 1. Okay, that was a difference of squares. We just factored it. Okay, this first factor, that is another difference of squares. That is, if we factor that, we get x minus 1, x plus 1. Now, the second factor, that is not a difference of squares. Or is it? Let's write it as x squared minus negative 1. We can factor that. So these two, we're stuck with those. X minus 1, x plus 1. And now I have turned this into a difference of squares. Just the negative's not showing up very well. So this is going to be x minus something and x plus something. Well, with our difference of squares, I think you guys often do this. You take the square root of both those things to split into your difference of squares. So the square root of x squared was the x, which starts both of our factors. Square root of negative 1? Well, of course, that's I. So this is x minus I, x plus I. So remember we said there were 4 zeros and 4 factors. Here they are. These are 4 linear factors. It's just a couple of them have some complex numbers in them. If you set each one of those equal to 0, your zeros are 1, negative 1, I, and negative I. So just like the fundamental theorem of algebra said, we have 4 zeros. Just a couple of them are complex. In the next video, we will talk about the rational zero test.